Zombie apocalypse.
Good morning, MAIE students. We're currently taking Electrical and Electronics Technology course. Once again, this is Sir Kenji E. Merenciano, your course facilitator. Maybe some of you are wondering why Sir Kenji decided to record, and later on, this will be uploaded and share this to our group chat. Since we're running out of time, and today is the last week before this mid-year ends. And I know some of you are busy working on their project, completing the requirements, which are the learning tasks, activities, experiments posted or uploaded in our Google Classroom. That's why I decided to record this video as your reference for the remaining topics. So as you can see, the topics that I'll be presenting are all about components. The first component that I'll be introducing, I know you are familiar with this. You've encountered or experienced this, or we discussed this for the previous topics. This components is all about resistor. So without further ado, here it is. So the topic that I'll be presenting is about components. So the first topic, or the first component that I'm going to present, is all about resistor. I know that we already encountered this from the previous topics or lessons that we discussed in electrical and electronics technology course. And as I've said, if you can still recall, a resistor is a fundamental component used both in electricity and electronics. Here, a resistor is a component of an electrical circuit that resists the flow of electrical current. It's an axial type of component. When we say axial type of component, it has both ends or terminals. It has two terminals across which electricity flows, and it is designed to drop the voltage of the current as it flows from one terminal to the next. A resistor is fundamentally used to create and maintain a known safe current with an electrical component. So in other words, resistor is a component or simply a device that limits, hinders, stops, blocks, or restricts the flow of current. The unit of measure for resistance is ohms, or represented by a Greek symbol omega. Class, as you can see, this is the actual picture of a resistor. As you observe, it's like a barrel or a cylindrical shape with a different colors, or it is represented by a color bands. The main purpose of the bands or the colors of in a resistor does not signify that is not for the purpose of aesthetic or the design. Each colors has a corresponding value. Later on, when we touch resistor color coding, you will understand and appreciate the meaning of each bands or colors. And this is the schematic symbol. If you can still remember, last meeting, we discussed or I presented about the different circuit diagrams, and one of which is the schematic. Wherein, as a student, electrical or electronics, or it could be an engineer, or enthusiast or hobbyist, each of us must conform or knows what the standard graphic symbols following the different standards like IEC, ANSI, or what else? IEEE. So these are the standards that conforms to the language of the industry when we're talking about electrical and electronics. Okay? So this is the different sizes of resistor, and each sizes has a corresponding watts from 2 watts to 1/4, 1/8, or 1 1/2. Okay? Now we already know what is a resistor, what is its function, including the units of measure and its symbol, and its application. Uh, we know already how does it look like, and its basic parts and sizes. Now this time, we're going to study the two main categories of resistor. We have the first one, the linear or fixed resistors. What are these type of resistors? These resistors obeys Ohm's law. Diba? If you can still remember Ohm's law, these are when we are talking about the relationship between the fundamental quantities of charge from voltage, current, and including resistance. Okay. So each component, let's say each resistor has a standard tolerance or value. Later on, we will talk about tolerance. What is it all about, and what its relation to resistors and resistance. And the other one class is what we call nonlinear or BR, or what we call variable resistors. The nonlinear or variable resistor consists of three common types. We have light dependent resistor, or the LDR. The second one is the thermistor. I know you heard of this when we had an activity about the familiarization of schematic symbols. And the third is we have voltage dependent resistor. Let's get to know more about fixed resistor. Fixed or linear resistors have only one ohmic value, meaning to say it's fixed already, it cannot be changed or adjusted. Can you look at the illustration below? As you can see, we have a, variety of resistors, and each resistor has a color. And don't you know that each color has a number, starting from black, which is 0, until a white color, which is 9. So fixed resistors, again, have a resistance that cannot be changed. Since it's already fixed, because resistors are tiny, it is impossible to label each one with its resistance value. That is why we use or colors, stripes, or bands tells you the value or the resistance of this component. While variable resistors consist of a resistance track with connections at both ends and a wafer. The wafer moves along the track as you turn the spindle. The track may be made from carbon, ceramic, or a combination of ceramic and metal mixture, or a coil of wire for low resistances. The track is usually rotary, but straight track versions, usually called sliders, are also available. As you can see, this is the a picture of a potentiometer with a wiper. So this wiper is responsible to change or uh, uh, to read or to determine the resistance, since it does not gives an exact or fixed value. That's why it is called a variable resistor. And the next illustration is the schematic or circuit diagram of a variable resistor. So a good example of variable resistor is the potentiometer, also known as PATS. Okay? They can be also called as potentiometers that can be adjusted to have a resistance within a certain range. Turning the dial changes the resistance between A and B and also changes either the current or or the voltage in the circuit. And since we know the two main categories of resistor, we cannot differentiate types of resistors based on its material. So here, we have the classification of resistor according to the type of material. So what are these for? So we have the carbon composition. The next is carbon film below the carbon position. Next is the metal film. And the last one is the wire wound type of resistor. First, let us discuss the first type of resistor based on its material, which is the carbon composition. These are made by hot or cold molding from a mixture of carbon and clay binder. So that is the carbon composition resistor. Another characteristic is it has a low cost reliability and general purpose of applications, and for its resistive tolerance, it ranges from positive or negative 5% or plus or minus 20%. Second, it has a resistive value ranges from 10 ohms to mega ohms. In power ratings, we have from 1.8 to 4 watts. Another thing, it has the ability to withstand higher current surges and ruggedness. It is used not only in commercial but for military and aerospace applications. So that is what we meant by carbon composition in terms of low cost reliability and including its resistive value ranges from 10 ohms to mega ohms. Its ability to withstand or to restrict current surges, and not only used for commercial but also for military and aerospace applications. So these are the parts of a carbon composition resistor. The first one class is what we call the metal connector and lead out. So these are the terminals found at both ends of this component. Next is the insulating jacket or the case. It's a covering for the main material for this type of resistor. And what's the common material for this is the solid rod of carbon granules. So these are the basic parts, and I forgot also the color bands or strips of this fundamental component. Next is the carbon film resistor. These are made from carbon graphite mixed with powdered insulating materials. It's deposited on an insulating substrate and a helix is cut in it to create a long, narrow, resistive path. So this type of component vary in shapes, coupled with the resistivity of amorphous carbon ranging from 500 to 800 micro ohm, can provide a variety of resistances. Carbon film resistors feature a power rating range of 0.125 watts to 5 watts at 70 degrees Celsius, and the other one is its resistances range from 1 ohm to 10 mega ohm. The carbon film resistor has an operating temperature range of negative 55 degrees Celsius to 155 degrees Celsius. It has a 200 to 600 volts maximum working voltage range. And this special carbon film are used in applications requiring high pulse stability. So these are the basic characteristics as well as the definition of a carbon film resistor. So what are the parts of a carbon film resistor? So this type of component are commonly available in electronics stores or supply. Um, so what are its parts? So we also have the ceramic rod. or the material inside this component. It has also a jacket or coating or casing. Next is the carbon film. So that's the main material of this component, which is spiraled away to give value. And we also the end cap or the metal cap, which is connected at the terminals or lead of the component. So, and the last, we have the metal lead. So these are the basic parts of a carbon film resistor. So the carbon film has three distinctive types. So we have the standard film. It's a circular resistor with two pins extending from opposite side or the barrel-shaped resistor. Another one is the chip resistors. So these are a small, tiny component which was introduced in the late 80s to accommodate the ever shrinking computer components where there can be up to 6 layers per circuit board. Okay. So this type of resistor can be found in your mobile devices, gadgets, or tablets. These chip resistors are surface mounted or what we call SMD, which stands for surface mounted devices. We use a specialized tool for installing or mounting this component to your breadboard, to what not breadboard, to your printed circuit board or the board. We also have network resistors. This resistor comes in compact form and can contain up to 12 resistors in compact space. So these network resistors are somewhat like an IC or integrated circuit that it can stores or uh, can one component which has 12 resistors, which has a built-in of 12 resistors. So these are um, the distinctive types of carbon film. So we have the standard film or the carbon film. These are what we call class chip resistor. It's a rectangular shape and it has no axial leads or terminals compared to standard film. So the next one is the network resistor. As you can see, it has several numbers of pins or terminals. So these are the three distinctive types of carbon film resistor. Metal film resistor is a common type of axial resistor today, and it's referred to as a metal film. Metal electrode leadless space or MELF often use the same technology but are cylindrically shaped resistor designed for surface mounting. It's formed by vacuum decomposition. It's a process by which any number of different metal or even metal oxide films are deposited on a suitable insulating mandrel or core. Another one, nickel and chromium are deposited on the alumina ceramic core and the unit is then subjected for laser trimming. Metal film resistors are built or processed, which is what we call laser trimming. Film resistors are laser trimmed in order to obtain the desired resistance value before the protective insulation coat is applied. For this next slide, let us determine or identify the parts of the metal film of resistor. So we have insulating material, same with the other previous mentioned components, the spiral globe, resistive film, and the connecting leads. The fourth type of resistor, according to its material, is what we call the wire wound. Okay, as you notice, based on the picture or illustration, you can see there is a wire wrapped around in for this component. So from the definition, wire wound resistors are commonly made by winding a metal wire, usually nichrome, around a ceramic, plastic, or fiberglass core. The ends of the wire are soldered or welded to two caps or rings attached to the ends of the core. The assembly is protected with a layer of paint, molded plastic, or it could be enamel coating baked at high temperature. Yeah, based on its characteristics, the wire-worn resistors provides low resistance, but it has high wattages ranging from 5 to 100 watts or more. So this type of component can has high wattages compared to the previous components presented. So this component comes in various shape, either flat, round, oval tube, but they're silicon coated or vitreous enamel. So when these tube selected wires are oxidized or bright, are wounded to reach the required ohmic value. So the value or the resistance of this component depends upon the wire, how it was wrapped around or wounded. Okay. Um, to reach the required ohmic value within the tolerance and connected to the terminals on both the sides by using spot welding, brazing, or bracing, if I pronounce it right, soldering or screwing techniques. So this is the process or the method of joining the metals. Okay, on both sides. Then insulation coating is applied after and is cured using high temperature ovens. Mounting arrangements are also given as per customer specifications. So this is the characteristics, or as you can see, we have different types, sizes, and shapes of the wire wound resistors. So for those who are not familiar or sort of or based on their curiosity, why is it that that a resistor has a corresponding colors or bands or strips commonly? Okay, so as I've said, each band of colors has a corresponding value. It has most of resistors has four, five, or sometimes six bands. But here, this is what we call class here in electronics technology, electrical electronics technology. We will study the resistor color coding. Why is it that uh, most of the resistors have four bands with different colors on it? And what does each color represent? As you can see, this is the for this next slide. You can see the different colors of each resistor and the meaning of each band. This is what we call resistor color code table. So let us try to decipher or try to know the colors per band and what does it represent or means. So as you can see, we have the first band. The first band represents. So as you can see, before with the bands, let us try to know the different colors in resistor color coding. We have black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, and silver. So all in all, we have at least nine color bands being used for each component. So as I've said, each colors or each band has a corresponding meaning. So when we say first band, it has we're pertaining to the first figure. Okay, so the first figure talks about the value in numbers for each color. So in the case of black, we have 0, brown is 1, red is 2, orange is 3, 4 yellow, green is 5, blue is 6, 7 is violet, gray is 8, and white is 9. For the second band class, oh, it is also represents the numbers as well as the colors. So we have same with black. For the second band, we have 0 until uh, brown, red until white, which is also a figure of 9. For the third band, each color represents a multiplier. Okay? A multiplier, we have 10 raised to 1 for brown, 10 raised to 2 for red, until gray. Okay? So we have 10 negative 1 for gold and 10 negative 2 for silver. So meaning to say, uh, if once you figure out the two bands, you have to multiply it depending on the color. So let's say the color is brown, which is 1, and the second color is red. So we have 1 and 2. So we already configured the two first colors, or the two first band, and then the next color is red. So we have brown, red, red. So we have 1, 2, and then the multiplier for red is 100. And the fourth band, or that is what we call tolerance. Okay. When we say tolerance in resistors, it talks about the um, again, when we say tolerance for a resistor, it's a deviation from the nominal value. Okay, it's expressed as plus or minus percent measured at 25 degrees Celsius with no load applied. Okay, so um, every resistor has tolerance. This provides the user with an idea of the accuracy of the product. This tolerance is represented by percentage. It does not give the exact value, but it provides the user the idea of the accuracy of the product. This means a big resistor will be less accurate than a small resistor with the same tolerance. Um, in other words, tolerance is the percentage of errors in the resistor's resistance, or how much more or less you can expect a resistor's actual measured resistance to be formed. Okay, so that is the meaning of um, tolerance. So here, for the fourth band, we have three colors with a corresponding tolerance. Like for example, in the case of red, we have plus or minus 2%. For gold, we have plus or minus 5%. And silver, which has a corresponding tolerance of plus or minus 10%. For no color, which is not mentioned here, the tolerance is plus or minus 20%. So this is now class the representation of the resistor color code table. That's why each color has a corresponding value or meaning. Okay? For example, uh, I have here a resistor with a color yellow. That's the first band. Second is blue. The multiplier is orange, and the tolerance is gold. So again, uh, the color is yellow, followed by blue, followed by orange and gold. So if we're going um, to decode the value or the resistance, uh, you will get four as the first band, to be followed by blue, which is six, and each multiplier is orange. So 6 times let's say 1,000. So you will get 46,000 um, ohms, and the fourth band is gold. So that is plus or minus 5%. So the answer is 46,000 plus or minus 5% ohms. But it would be better if we're going to shortcut the word 46,000 using the kilo, since 1,000 is equivalent to kilo. So we will use 46 kilo ohms plus or minus 5%. So that is the actual value of, based on the examples given. Okay? So that is the resistor color coding. So as I've said, resistors are often indicated with color codes. Practically, all leaded resistors with a power rating up to 1 watt are marked with color bands. The coding is based on the international standard or the IEC 662, wherein this standard describes the marking codes for resistors and capacitors. It also includes numerical codes as for example often used for surface mounted devices resistors, like for example the chip resistors. The core code is given by several bands. Together they specify the resistance value, the tolerance, and sometimes the reliability or failure rate. The number of bands varies from 3 till 6. As a minimum, 2 bands indicate the resistance value and 1 band serves as a multiplier. So based on the picture, you can see you can see the difference, the 4 band code and the 5 band code resistors. For the 4 band code, the first two bands represents digits or figures. For the third band, we have the multiplier, and the last band is the tolerance. For a 5 band code resistor, the first three colors represents the digits or the value, while the fourth band is the multiplier, and the last or the fifth one is the tolerance. So this how these two bands differ from one another. So each color represents a number if it's located from the first to second band for a fourth band type, or first to third band for a five band and six band type. Mnemonics were created for you to of as electronics, electrical students, even electrical engineering or electronics communication engineering, or even enthusiasts, hobbyists, uh, electronics professors or electrical professors. Um, for you to be familiar with the colors, sometimes we use mnemonics. Mnemonics were created to easily memorize the sequence of the colors. The most popular mnemonics for these colors are we have the black, brown, red, orange, yellow, green, blue, violet, gray, white. Instead of memorizing these colors, just convert the colors into names or a mnemonics. So instead of black, brown, we will use big boys. Big boys race our young girls, but violet generally wins. So it's big, brown, red, orange, yellow, uh, green, blue, violet, gray, and white. Okay, where the first letter of each word corresponds to the first letter of the color. Before, when I was a high school student, when I encountered this color code, we have different mnemonics, which is I know kind of sensitive. Uh, correct. Let me correct the term. Ano, the mnemonics for the colors goes like this. Bad boys rape. Okay, bad boys rape only young girls, but Violeta gives willingly. God says no, which is uh, which is not good to hear, not pleasant to the ear, and not gender sensitive. So that's why from that mnemonics, it was replaced to like this one. So big brown red. So big boys race our young girls, but violet generally wins. So that's the mnemonics for the color and its value. If the color is found on the third band, the fourth or the fifth band, then it will be a multiplier. So black is we have times 1, brown is for times 10, red is times 100, and as you can see, white is higher. Okay, so this is how the third band or the fourth band for or the fifth or the sixth band uh, meaning. So this is the multiplier. Uh, Notice that the number of zeros is equal to the color's number as per previous table. The fourth band or the fifth band and sixth band indicates the tolerance value. So here are the complete corresponding tolerances for each color. So we have brown, which is plus or minus 1%. And as you can see, silver is plus or minus 10%. Gold is plus or minus 5%. So these are the um, um, tolerance. So the this is for resistors with a six bands. So the six band of a six band type resistor is the temperature coefficient. This indicates how much the actual resistance value of the resistor changes when the temperature changes. So we have brown, which is 100 ppm degrees Celsius, until violet. So these are the corresponding temperature for each component. So the four band color code is the most common variation. These resistors have two bands for resistance value, one multiplier and one tolerance band. So for example, on the left, these bands are green, blue, red, and gold. By using the color code chart, one finds that green stands for 5, correct? 5 is green is equals to 5, and blue is for 6. So the value is thus 56 times 100. So you will get 5,600 ohms. So 5,600. So if we're going to convert that using the kilo ohms, so it's 5.6 kilo ohms. The golden band means that the resistor has a tolerance of 5%. That's meaning to say the resistance value lies therefore between 5,320 and 5,880 ohms. So if the tolerance band without be left blank, the result is a 3-band resistor. This means that the resistance value remains same, but the tolerance is 20%. So this is what I'm saying. If you can still recall, what if the fourth color or the fourth band has no, I know, the third color or the third band has no, what do you call this? I don't know. The fourth color of the four band type resistor has no color. Even though it has no color, it has an equivalent tolerance. So if we say silver, it has 10 plus or minus 10%. But for the case of gold, we have plus or minus 5%. But when we're talking about no color for the port band, it still has a tolerance of plus or minus 20%. Okay? So what are the things you need to consider, or these are the important reminders for reading resistor codes? In the section below, examples are given for the different numbers of bands, but here are some tips given to read the color code. The reading direction may not always be clear. Sometimes the increased space between band 3 and 4 give away the reading direction. Also, the press band is usually the closest to a lid. A gold or silver band tolerance is always at the last band. So take note of this. So when trying to read the value of based on the bands of the resistor, gold and silver is always at the last. So meaning to say, if you see um, gold or silver, uh, you need to read it on the last, or that could be possible. These are what they call tolerance of the component. It is a good practice to check the manufacturer's documentation to be sure about the use coding system. Even better is to measure the resistance with a multimeter. In some cases, this might even be the only way to figure out the resistance. For example, when the color bands are burned off. So, um, we don't easily rely on the bands of the component or the color bands of the component. To make sure to get the appropriate value, we can resort to using a multimeter. A multimeter is it's a measuring device used to determine the value of a component. Its voltage, its resistance, its watts, depending on the rating that you use. And it is also used for troubleshooting to check and to determine if there is a problem with your component, and even for troubleshooting and repairing of some devices or domestic appliances. For example, here are the given examples so that for you to understand the resistor color code chart or the resistor color coding. So a resistor color code yellow, violet, orange, and gold would be 47 kilo ohms with a tolerance of plus or minus 5%. Okay. How about green, red, gold, silver color code as the given color value? So green is equivalent to 5. Red is, I think, 2. So gold is point times 0.05 or zero point 0.5. So you have to compute 5 tama ba? 5 2 times 0.05, you will get 5.2 ohms with a tolerance of plus or minus 10%. Another, we have white, violet, black color code. So the white, violet, black would be 97 ohms with a tolerance of plus or minus 2%, 20%, since the last band has no corresponding color. So it's automatically, its tolerance is plus or minus 20%. The next one is orange, orange, black, brown, violet color code. So we have 1, 2, 3, 4, 5. It's a 5 band component. So if you have orange, two orange, black, brown, violet, just take note of this. The first three colors represents the significant digits. Okay. The fourth one is the multiplier, and the fifth is the tolerance. So you will have 3.3 times 3.3 kilo ohms plus or minus 0.1%. Since the last band or the last color is violet. Next is brown, green, gray, silver, red. So the corresponding value is 1.58 ohms with a tolerance of plus or minus 2%, since red has a tolerance of plus or minus 2%. So these are based on the examples, we have 5 band resistor. So for the blue, brown, green, so we have 6. Brown is 1, green is 5. Silver is times 0.1. Yeah, correct me if I'm wrong. So you got 6.15 ohms plus or minus at 0.25%, since the last band is blue and its corresponding tolerance is 0.25%. So hopefully by now, class, you understand that resistors come in variety of sizes and values. But to have a resistor available for every possible resistance value, literally hundreds of thousands, if not millions of individual resistors would need to exist. Instead, resistors are manufactured in what we commonly known as prepared values. Instead of sequential values of resistance from 1 ohm and upwards, there are certain values of resistors exist within certain tolerance limits. Let's say the tolerance of a resistor is the maximum. That's why in resistor color coding, um, in you cannot easily determine or the color code does not provide the exact value. Okay, that's why we have this called tolerance to determine its maximum or minimum resistance value. So the tolerance of a resistor is the maximum difference between its actual value and the required value is generally expressed as a plus or minus. That's why for each tolerance, it has a corresponding of plus or minus. Okay. For example, 1 kilo ohm plus or minus 20 tolerance resistor may have a maximum and minimum resistive value. So we have, for maximum, you have 1 kilo ohms or 1,000 ohms plus 20% is equals to 1,200 ohms. For the minimum resistance value, we have 1 kilo ohms or 1,000 minus 20% and you will get 800 ohms. The maximum resistance value, you will get 1,200. For the minimum, you have 800 ohms. Then using our example above, a 1 kilo ohm plus or minus 20% tolerance resistor may have a maximum value of 1,200 and a minimum value of 800, resulting in a difference of some 400 ohms for the same value resistor. So class, that is how we end our topic for the for the resistor color coding. Uh, uh, to summarize, to have a short recap, we know what a resistor is, the definition, and its application, wherein a resistor is a fundamental component that restricts or limits the flow of current. It is measured in ohms as the unit of measure, and its value can be determined by ohms or the omega symbol. Here we were able to study the different color bands. For some, they thought that the colors are for design or for aesthetic purposes. But here, in electronics and technology, colors play a vital role in determining the resistance value of a component. So for 4-band resistor, the first and second stripe or band represents the digits or the significance value. So each color has a corresponding value. Let's say black is 0, brown is 1. Okay. So just be guided with the mnemonics for you to be familiar with the value for colors. For the third band, it is the multiplier. Each colors has a corresponding multiplier. And then the last one is what we call the tolerance. This is the minimum or maximum value of the component. And we were able to get the maximum resistance and minimum resistance based on the formula given. So we already now understand the parts of the resistor and its application, as well as the color coding chart. That's how I end my presentation. I hope you've learned new things or information about this fundamental component, which is the resistors. So if you still have questions, clarifications about this lesson, feel free to message me. You can see the contact details below. Or if you have if you have certain things that you want to clarify, let's say concerning about the requirements and then the status of your project, do not hesitate to message me, and my lines are always open to address your concerns. So class, thank you for your time. Thanks for listening. I hope you enjoyed this video. And what based on what I always say, keep safe always.
Zombie apocalypse.